You don't have to.
See, now it's going to get bad. Now, so you shouldn't have told us.
Hi guys, this is Alex. Alex from Combination Robotics again, and I promised that I would show you guys how the process works for programming to avoid falling off the edge of the board the other day. So I'm going to do that. First, I got to get rid of this old software here that I've got written. There we go. Okay, so what I'm going to do is I'm going to have the robot function in a switch, and because it's going to be working autonomously, I'm going to put everything in a loop. Right, everything's going to go into a loop. So I'm going to put the switch inside the loop there. I'm going to have it run for infinity, and I'm going to change the sensor here to that's one of my students back there. Wave, hi. Not you. All right, so I'm going to change this over to color sensor, and I'm going to put it in compare reflected light intensity. So what that's going to do is it's going to measure the amount of light that the sensor is receiving. So let's take a look at the Virtual Robotics Toolkit here, and I'll show you what I mean. So I can navigate in here and to the port view right there, and click enter, right? So now it's showing me that the sensor on port 1 right here is seeing 16% of reflected light. So it's on a dark surface. So dark surfaces don't reflect as much light, right? So it's only getting 16% of this red light that it's pushing down. It's only receiving 16% of it back. It must be this one. All right, so when it's, whoa, almost too far. So when it's over on the edge, it's actually receiving 65%. So that difference allows us to make sort of a math equation to tell the robot what to do. Robots think in math. They think in numbers, right? So what we're going to say is if you're on dark, so if you see dark, which is somewhere around 16, then drive forward. If you see light, stop. Don't go any further forward, and then turn around. So dark is 16 and light is 65. What we do is we just kind of pick a number that's in between. It doesn't really matter exactly what you pick. I'm just going to pick, let's say 40. And that's going to become something called a threshold value. So I'm going to say 40 is my threshold value. So if the sensor on port number 1 sees something that's less than 40, so if it's less than 40, it's seeing dark, right? If it sees something less than 40, what we want the robot to do, we want the robot to drive, right? So we're just going to have it turn on and drive straight. Now, what do we want it to do if it sees something greater than 40? So this is the false case down here. So if it sees something greater than 40, we want the robot to actually stop and back up, let's say. So I'm going to have it drive -1 rotation. Right, so that would be backwards. That's one way to do this. So you could say -1, or you could say go at -50 power, whatever you want to do there. But I'm just going to say drive -1 rotation. So it's going to back up, and then I'm going to have it turn to the right. I'm going to turn to the right, let's say about 0.7 rotations. Right, and I'm going to hit play, and we're going to see what this does. All right. There we go. So the robot's driving forward until it sees the edge, and then it backs up and turns. Ooh, that was lucky. Yep, and it will continue to do this forever. Now, it's the sensor on the right, not the sensor on the left. So you saw right there that there's an issue. What I really need is for both sensors to have this same kind of logic behind them, not just one. So you could do that in several different ways. You could run 2 programs simultaneously. So I could kind of Control-C and Control-V this whole piece of software again, right, like this. And run them both simultaneously by moving the data wire to both. But that seems kind of complex, and there's got to be an easier way to do that. So I'm going to show you how to kind of nest something in there. So we know that when it fails, what is the robot doing at the moment that it fails? It's driving forward, right? So I lost my play button there somehow. There it is. There's one. Oh, let's get that again. Grab that. And there we go. Okay. So when it fails, when it falls off the edge, it's in this state here. It's driving forward. So instead of this block here, I can just delete that block, and I'm going to put another switch in there. All right, and this switch will control the other sensor, port number 3. And I need to make sure that it's a color sensor as well, and that it is comparing reflected light intensity again, and that my threshold value is the same. So now, if this is okay, instead of just driving, it will check to see what this one is. So if both sensor 1 and 3 are good, then it's going to drive forward like this. All right, and otherwise, I'm going to have it turn around. I'm just hitting Control C, Control V there. But I'm actually going to have it turn in the opposite direction. Let's see here if I can get it to select, which I'm having some trouble doing. Okay, we'll just run it like this. All right. There we go. Okay, so let's take a look this time. Back up and go, back up and go. All right, so now it's reacting to either one of the two sensors falling off the edge. There, I'm going to push most of those pieces off of the board. There we go. There. All right, so it will just continue to do this pretty much forever. It'll be fairly stable now because of the fact that it will stop and turn around no matter which side, no matter what angle that it's going on. So if you combine this with the algorithm for finding the pieces that I showed you last time, you have most of a complete solution to this. So I'll let you guys try that out. Okay, until next time, see you later.